Lesson 13, Fourier series. Section 13.3, Fourier series. We can use AC analysis for each harmonic voltage. To find the parameters of each harmonic component, those are amplitude and phase shift, of a given non-sinusoidal voltage, we use Fourier series decomposition to calculate the Fourier coefficients. A periodic function can be represented by an infinite sum of sine and cosine functions, where the period is denoted by uppercase T, and omega t equals 2 pi. We call the infinite sum of sine and cosine functions Fourier series. A0, A1, B1, A2, B2, are called Fourier coefficients. A0 represents the DC component. A1 cosine omega t plus B1 sine omega t, represents the fundamental component. A2 cosine 2 omega t plus B2 sine 2 omega t, represents the second harmonic component. This is an example of Fourier series that represents a square wave ft. The square wave contains a fundamental sine component and odd-numbered sine harmonics. If the function ft is given, the Fourier coefficients A0, AK and BK are obtained from ft using these equations. The DC component A0 is derived as follows. Ft is substituted with a Fourier series. These terms containing cosine or sine functions are 0. This is because the positive and negative parts of cosine and sine functions are symmetric over the period t. To confirm, you can carry out these integrations. Thus the DC component A0 is obtained. The coefficient AK is derived as follows. Ft is substituted with a Fourier series. This term is 0. There are two cases in these terms. If n equals k, then it is AK, and if n is not equal to k, then it is 0. These terms are 0. To confirm, you can carry out this integration. This trigonometry formula is used. If n equals k, then the integration is obtained as ak. If n is not equal to k, then it is 0. Exercise 13.3.1. Pause the video, and show how Bn is derived. The answer to exercise 13.3.1. Pause the video, and check the answer. Exercise 13.3.2. Show that the Fourier series of this square wave is given by this equation, where Vm is the amplitude, and uppercase T is the period. The answer to exercise 13.3.2. A0 equals 0. An equals 0. Bn equals 1 over n times 4 over pi times Vm, if n is an odd number. Thus, the coefficients of trigonometric functions are given by this equation. Exercise 13.3.3. This is your homework. Find the Fourier series for this square wave. This is for your reference. The Fourier series for this triangular wave is given by this equation. This is another example. This sawtooth wave is expressed by this Fourier series. The next question is, how can we measure the Fourier coefficients? The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.